So when we're creating a study, we want to find information about a population, and that population could be as small as 5 goldfish in a bowl, and it can be as large as the world's population. From there, we want to collect data on that population, and when we collect data from every single member of that population, that is called a census. And from there, most of the time, a census is not feasible. It's just too expensive or time consuming, and so almost all studies include the idea of a sample, which is a subset of the population. And from that sample, if it's well chosen, we can make inferences about that population. So when we're designing surveys, we want to make sure that that sample is representative, and then we can make inferences. So a sample survey sounds like we're answering questions about something, but a sample survey is actually your plan. Your plan of how you're going to collect your data so your sample can be a representative of your population, so you can then make inferences. So a sample survey is going to tell exactly what your population is, what you want to measure, and then how you're going to choose a sample for that. And we're going to talk about different methods. So there are a couple of things we need to talk about, and there are lots of bad sampling methods out there, but the key issue is, once again, your sample survey is to allow you to trust that your sample is representative of the whole population. And so here are a couple of crappy ways for you to sample. One is to just choose the people that are closest to you. So as I did in class, I chose to ask you all a question, and if I was only asking of our class and I only wanted information about our class, then it would be a census of the population. But if I were trying to use our class as a representative of all of Novato High School students, or even AP Stat students, it's a convenient sample, and there might be some bias that is involved. And bias is a term that's used in lots of different ways, but in statistics it means bias either by the structure of the sampling or by the wording of questions in a survey that would consistently underestimate or overestimate the value of what we want to know. So for those of us that like little visuals, here is an opportunity to look at how a convenient sample might make it easier on the researcher, but in the process, in this case they're just looking at proximity. None of the purple people are included, and therefore the ability to make inferences about the whole population without some of the members of the population involved would have to be recognized, or it's flawed. Another way to sample badly is when people get to decide whether they're going to join a sample. It's an open invitation. It's not just looking for a random sample, but you can go ahead and answer a survey or answer a poll, and that's voluntary. And obviously when it's voluntary, the people with strong opinions, often in the same direction of that survey, are the ones most likely to respond. So that's really going to overvalue or overestimate a particular thing. So voluntary response sampling means you're choosing to answer. You haven't been, everybody in a particular sample hasn't been asked, but it's a volunteer situation. And this particular one for Obama was on a website called cost.com, which is a pretty strongly left-leaning liberal website. And of course, the people that are going to choose to take the time to answer that are probably ones who lean toward the kinds of politics that Obama personified. Whereas this one comes directly from President Donald J. Trump's website, and the questions that are here, they're being asked, and the people that are going to choose to answer them are probably ones that are going to be more supportive of the policies of Donald J. Trump. So volunteer response sampling is definitely going to overestimate certain things based on the people who choose to take their time to answer it. If we were going to try an offset bias, we're going to want to make sure that our sample doesn't rule out convenience for the researcher or self-selection by the respondents. And so that's where we get random sampling. And simple random sampling just says that we're going to look at a certain size so that every group in that population, and we're going to choose n of them, has an equal chance of being selected by the sample. Very often, random number generators are used by a computer or a calculator to choose samples, and then we're also going to look at tables of random digits, which is something you need to know how to read, particularly for the AP Stats test, but most people now use computers or calculators. So when we are getting a simple random sample, we're going to be always looking for how many in our sample is lowercase n. And capital N is going to be our number in the population. And the first thing you're going to do is give each individual in that population a number from 1 to whatever the total number is. And then you're going to use a random number generator to obtain, remember, n different integers. So different, remember you need to get unique ones. So if there's a repeat, you're going to go ahead and throw that back and pick another one. Using table D, we're going to talk about that in class. It makes more sense to just do it in person. So in the Federalist Papers, there were 2 sample surveys. The first one was our original sample survey. The way we did it was there was a sample of n equals 5, so 5 words were chosen, but the choice of the words was left to the data collector. And when we had our 27, 28 data collectors, there tend to be a bias where the longer words were overrepresented. The second survey sample or design of a survey, there was the same number of words chosen, but instead of it, the choice of the words being left up to the data collector, it was a simple random sample where each word was assigned something between from 1 to 130. Remember, I've got 3 digits here, I've got 3 digits here. Has to be like that. And you communicate that you're going to skip any numbers that are repeated. So if I got 38 and then I got 38 again, I would wait until I add a unique number. And this showed less bias. I think I said 4.6 is the actual average length in that passage. So when we do a survey sample, we've got to make sure we choose to do it in a manner that eliminates bias as much as physical. We're going to go ahead and look at how to choose an SRS. This one talks about using table D. We're going to use that in class and also using random number generator a lot. But the key idea is you're starting by letting each item in the population that has a chance of being called or chosen in the random sample is going to have a number. And so notice that in this case there are 28 total hotels, and we want to choose 4 of them. We're going to name each hotel with a specific number. Aloha is 01 and Casa de Mar is 09, and then you either use your random number generator with, if you had a random number generator that you're using on your calculator, your range would just be from 01 to 28. But if we're using table D, which we're going to do in class, you would look at each number. I'm going to explain it more in class, but basically you're looking at the fact that the first number, 2-digit number, is 69, which does not have a value for us. Then 05 has a value, and so 05 would give us the beach castle. This is highlighted wrong. Gives us beach castle, and then 16 gives us the Radisson, and then 48, which is the next set of numbers, gives us nothing, so we don't choose something, and then 17, which gives us the Ramada, etc. Until you have 4. Notice 17 was hit a second time, and we would replace that and continue going until we hit, oh, there's 17 again. until we hit the next 20, which is the C club. This is highlighted funny. Bring your questions.